Hi everybody, welcome to our second section of thermodynamics. In this session, we will discuss about Carnot's theorem. According to this theorem, no engine can be more efficient than reversible engine working between the same two temperatures. Here, Carnot stated that no engine can be more efficient than reversible engine working between the same two temperatures. This may also be stated as all reversible engines working between the same two temperatures have the same efficiency, whatever may be the working substance. Here, according to Carnot, he also stated the theorem as all reversible engines working between the same two temperatures, we considered the same two temperatures have the same efficiency, whatever may be the working substance. To prove this Carnot theorem, let us consider irreversible engines. So, to explaining this Carnot theorem, we can consider a reversible engine and irreversible engine I working with the same source and sink. We considering here reversible engine and irreversible engine which are working between the same source and sink. Hence I works as here I is considered as irreversible engine works the forward direction while R reversible engine works in the backward direction. Let engine I absorb an amount of heat. It means amount of quantity of heat Q from the source to convert a part of it W into the work and transfer the balance Q minus W to the sink. Similarly, engine R absorb an amount of heat Q dash from the sink. A certain amount of work W dash is done and that working substance and transfers the net amount of heat as Q dash plus W dash to the source. As shown in the diagram here, engine I, engine R, these are two working between the same source and sink. Here they absorbing quantity of heat and this doing some work and giving to the here the source. Here we assume that the source itself with no change. It means we giving some quantity of heat and doing some work and it transferring the heat. Here the source is no change, that is the amount of heat which I receives from the source is returned by R to the same source. Engine I, whatever may be the receives which gives the engine R to the same source. Hence Q dash plus W dash, here the quantity of heat plus work done which is nothing but quantity of heat Q. Then we can write W dash which is equal to Q minus Q dash. If possible, let the irreversible engine I be more efficient than reversible engine. If we consider as let the irreversible engine I be more efficient than reversible engine, or efficiency of engine I is greater than efficiency of engine R, then we can write, we already learned about this efficiency in Carnot heat engine. We can write the efficiency for Carnot theorem as engine I and engine R as W by Q greater than W dash by Q. Here W by Q is the efficiency for irreversible engine and W dash by Q which is the efficiency for reversible engine. Here the efficiency of engine I is greater than the efficiency of engine R. It means irreversible engine is more efficient than reversible engine. Then we can write W by Q which is greater than W dash by Q dash. It means work for engine I which is greater than work done for engine R. Then we can write W is greater than W dash. This is treated as equation 1. Now imagine that the two engines are coupled by a belt as shown in figure. Then engine I works directly and it drives the engine R reversibly. As shown in the here the diagram, hot source T1K and cold sink T2K. Here engine I and engine R, these are working between the same source and sink. Here engine I and engine R works between the same two temperatures of equal source and sink. The compound engine extracts an amount of heat Q minus W dash from the sink and gives an amount of heat Q to the source. Therefore the net amount of heat from the sink which is nothing but Q minus W dash minus Q minus W which is nothing but W minus W dash. This is treated as equation 2. According to engine I, here engine I working above fact shows that by coupling engine the heat absorbed from the sink nothing but Q minus W dash is greater than heat given back to the sink Q minus W while the source is unaffected. It means according to equation 1, the above fact, here the coupling engine, it means the two coupled with the same belt we considered here, the heat absorbed from the sink Q minus W which is greater than the heat given to the sink as Q minus W. Then the source is not affected, we considering. In this way, any amount of heat may be taken from the sink, work done, and no change may be left with the source. It means quantity of heat extracting and some work is done and liberating, then there is no change may be left with the source. This is impossible according to second law of thermodynamics, which contradicts this. Here, according to second law of thermodynamics, it is impossible for any self-acting machine unaided by external agency to convey heat from one body at higher temperature to another body at lower temperature. So this contradicts our assumption. It means how much work is doing and there is no change, there is no loss of heat in the source. This is impossible according to second law of thermodynamics, which states for any device to extract heat from a simple reservoir and converting the whole into work. Hence our assumption, the irreversible engine is more efficient than reversible engine, is wrong. So does no engine working between the same source and sink be more efficient than a reversible engine? So to prove the second part of the theorem, it means here we considered reversible engine is more efficient than irreversible engine. So our assumption is contradiction in second law of thermodynamics. Then we considering to prove the second part of the theorem, which is let us consider the two reversible engines. It means A and B working between the same source and same sink. If we consider that A device drives B in backward direction, then A cannot be more efficient than B. Similarly, if we suppose that B drives A in the backward direction, then B can't be more efficient than A. So the two engines are equally efficient. The efficiency of a reversible engine depends only on the temperature of the source and sink and is completely independent of the nature of the working substance. By this, we can conclude that the efficiency of reversible engine depends only on the temperature of the source and sink and is not completely independent of the nature of the working substance. This is about Carnot's theorem. Under Carnot's theorem, two statements can be explained with the help of considering irreversible engine and irreversible engine, and they are working separately and they are coupled with a belt. In this way, we can explaining this Carnot's theorem. I hope you are understanding this Carnot's theorem. Then we go for second law of thermodynamics. This second law of thermodynamics we already learned. We have only the definitions for second law of thermodynamics. One is Kelvin's statement, another one is Clausius statement. According to Kelvin's statement, it is impossible to derive a continuous supply of work by cooling a body to a temperature lower than that of coldest of its surroundings. It means to derive continuous supply of work by cooling a body to a temperature coldest than its surroundings. This works in the refrigerator, which is impossible. So explanation for this second law of thermodynamics, this statement is based on the working of heat engine. According to Kelvin's statement, to work a heat engine, there should be a difference in temperature of source and sink. Otherwise, it is not possible. Engine works with the same single reservoir. And another statement for second law of thermodynamics is Clausius statement of second law. Here one is we discussed, which is nothing but Kelvin's statement. Another one is Clausius statement. Here Clausius statement is like that. It is impossible for a self-acting machine unaided by external agency to convey heat from one body at higher temperature to another body at lower temperature, or it is impossible for a self-acting machine unaided by external agency to convert heat from cold body to a hot body. It is also based on the working of refrigerator. No, refrigerator works when it is not aided by external agency. That means there is no change to prepare a self-acting refrigerator. So these are the two statements for second law of thermodynamics. One is Kelvin's statement, another one is Clausius statements. This is about second law of thermodynamics definitions with brief explanation. And next our topic is entropy. Here in previous classes we discussed about Carnot's theorem, Carnot's heat engine, isothermal adiabatic processes, isothermal expansion, adiabatic expansion and compressions and working substances. Now we discussing about entropy. This is a thermal property of your body which remains constant during adiabatic process. Entropy is a different concept Here in entropy, the thermal property of a body which remains constant during an adiabatic process is called an entropy. Entropy is indicating with a letter or denoting with a letter S. So a physical quantity, nothing but a thermal property of a body which remains constant during an adiabatic process is called an entropy. The entropy is denoted with the letter S. So this entropy can be easily understood by plotting a graph, PV graph, indicator graph, as peak on y-axis and volume on x-axis. Then we consider some isothermals and adiabatics as AB as isothermals and adiabatics with the temperatures. Here consider a number of isothermals at temperatures T1, T2 and T3 as shown in the diagram, and so on. On pressure volume diagram as shown in the figure, let A and B be the two adiabatics. Here considered capital A and capital B. These are adiabatic curves. We know isothermal curves, water and adiabatic curves. So the adiabatics cuts the isothermals as at A's. Here these are small a, small b, small c and small d, small e, small f. These are the cutting points. So here these controls and cuttings these isothermals and adiabatics. Consider reversible Carnot cycle. In this we assumption as a small Carnot cycle ABCD in the diagram. Consider reversible Carnot cycle ABCDA for its working substance between the temperatures T1 and T2. Suppose Q1 be the heat taken at a temperature T1 and Q2 be the quantity of heat rejected to a temperature T2. Then we can write. Here we are considering some isothermals and adiabatics as PV indicator diagram, and these isothermals cuts the adiabatics as at temperatures T1, T2, T3 as we take a small Carnot cycle ABCDA. Then we can write Q1 by Q2 according to Carnot's heat engine. Here we can write Q1 by Q2 which is equal to T1 by T2. Then we can write Q1 by T1 which is equal to Q2 by T2. In general, this can be applied for all the Carnot cycles if we considering the entropy topic. Q1 by T1 which is equal to Q2 by T2 which is equal to Q3 by T3 and so on. Then we can write Q by T which is equal to constant. It means the quantity Q by T is definite thermal property of the working substance and is termed as entropy. It can be shown that the quantity Q1 is independent of manner of transformation. Here the quantity Q by T definite thermal property of the working substance. Thus entropy can be defined as, the entropy is defined as function of internal state of the body. It is the internal state of the body. Entropy is a definite physical entity like pressure, volume, but there is nothing physical to represent it. It is a entropy is like a pressure, temperature, it can be indicating, but it is a physical, nothing to physical to represent it. This is the about entropy. And next, physical significance for entropy. I hope you are understanding. Entropy is a definite function of internal state of a body. Entropy means a definite function of internal state of a body. It is a physical term to represent it, Q by T which is equal to constant, and it is indicating with the letter S. Physical significance of entropy. Entropy may be thought of a quantity which based to heat motion, similar to relation to mass based to linear motion and moment of inertia, rotational motion. Hence entropy is a thermal inertia. That means when the entropy of the system increases, available heat energy converted into mechanical work and decreased. So entropy measures randomness or degree of disorderness. Entropy measures the degree of randomness or disorderness of molecules of a system. This is about entropy. I hope you are understanding in this session about Carnot's theorem and Clausius statement and Kelvin statement, and also this entropy concept. And another session we will discuss another topic like entropy concepts.